Okay, hey everyone. Welcome to another video, and I present to you another problem that I made. It's about finding the maximum output of a function, and it is a pretty long function, but let's see where we can get by just simplifying and playing around with it. So, first of all, what I see is I see a 9, 9, 9, and a 9, and then a 3 over here. So, because they all have all the terms of 9, we can definitely simplify it to 3 and take it out of here. So let's do that. And we can say that this will become 3 sine 2x cosine y. Let me write this better. Sine 2x cosine y plus 3 cosine 2x sine y plus 3 sine y plus 3 cosine x. And this is all over the term cosine x. Okay, so now I see two things that we can either simplify or take out. I do see that there's a cosine x in the denominator that if we can maybe like divide out by other terms that we can further find out when we simplify the top part of the fraction. And we can simplify the top part of the fraction by expanding these terms over here, sine 2x and cosine 2x. So let's just do that. We should know our identity of sine 2x being equal to 2 cosine x sine x. Yeah, and then we should also know about our cosine 2x identities. There are actually quite a few, but because I am trying to single out my cosine over here, I'm going to simplify this cosine identity into uh, another identity that has cosine within it, and the only one that does is the one that says cosine 2x is equal to cosine 2 cosine squared x minus 1. Okay, so I'll be using those two identities, and if we do that, we will be able to figure out that we can rewrite this as this cosine x sine x times cosine y plus 3 2 times cosine squared x minus 1 times sine y plus 3 sine y plus 3 cosine x. Okay, so right now what we can see is that I'm going to leave this cosine x in the denominator because I don't want to write it for every single step I do for simplification, but mental note that there's a cosine x in the denominator. But what I see right now is that if we distribute this 3 into this cosine 2 cosine x and minus 1, and we can distribute that with a sine y, this 3 times negative 1 times sine y will become negative 3 sine y, and then this is a positive 3 sine y right next to it, and then that will end up canceling out, which I like. So let's try doing that. Let's just simplify it down as much as we can. So let's say 6 cosine x sine x cosine y plus 6 cosine squared x minus 3 sine y. Oh, we have to remember here it's really important again to not forget that the sine y is being distributed to both of the terms. So we have to write 6 cosine squared x sine y minus 3 sine y plus 3 sine y plus 3 cosine x. Okay, so this thing over here will cancel out for us, which is great. we like that. And I noticed that we can, after that, we can actually factor out this cosine x from all three of these terms, which will be able to be canceled out from the denominator that we had earlier. So what I'm going to do now is I'm going to say 6 cosine squared x sine y plus 6 cosine x sine x cosine, cosine y plus 3 cosine x, and this is all over, oh, that's a bad line, cosine x. Okay, now let's factor out the cosine and see what we get. So we can do cosine x on the outside and say 6 cosine x sine y plus 6 sine x cosine y plus 3, all divided by cosine of x. This cancels and this cancels. Now what we are left with is this thing on top, which, let me move this way, go to the side. Let me scroll down. Which will give us 6 cosine x sine y plus 6 sine x cosine y plus 3. Okay, so that is way cleaner now, but we can still do a little bit of a little bit more simplification here. If you recall that the sine double angle, no, the sine sum theorem, sine x plus y is equal to sine x cosine y, sine x cosine y plus cosine x sine y. Oh, there's not a space. It's right here. Sine y. Okay, so that's another identity that we can use, because essentially what will happen is that when I factor out the 6 from here, we can get cosine x sine y plus sine x cosine y plus 3. And then this thing over here can just be replaced by this because it's the same thing. Just swap, but addition is commutative, so we are good to replace this with sine of x plus y plus 3. Okay, now we want to find the maximum of the function. That's what it says. We want to find the maximum output of the function below. So what is the maximum output for the function sine? It is 1, right? Because sine of 90 degrees is 1. So the maximum outputs that sine x plus y could be is just 1. And then when you add 3 to that, and we substitute 1 over here, and we multiply by 6 and add 3, we can get 9. And that right there will be our final answer. Alright, thank you for watching. Let me know in the comments if you have any questions or any other ways you solved it yourself. I'm more than happy to read them. See you.